Hello everyone and welcome to a new video on my channel. In this video, I am going to talk about remote procedure calls, or in short form this is also called as RPC. So first we will look at what is RPC, then we will look at popular RPC frameworks, and we will also look at one of the popular RPC framework, that is gRPC, with an example. Then we will look at what is the difference between RPC and REST, and at last we will look at what are different use cases of RPC. Then we will look at what is the difference between RPC and REST, and at last we will look at what are different use cases of RPC. So before we go to RPC, let's first look at procedure or function calls. In each programming language, we have support for functions. For example, in Python, we have the keyword def, which defines a function, and then we have the name of the function, add here, and then you pass the parameters to the function, that is num1 and num2 here. After that, you implement the function by writing some code, and at the end, you optionally return some values from this function. In this case, I am not doing any processing in the function. I am just returning the values of num1 plus num2. And then in the main, you call this function with the function name, and also you pass the parameters. In this example, I am passing 5 and 7. So let's understand what happens when we run this program locally on our system. In that case, first this program gets loaded into the main memory, somewhere in the main memory, and of course there will be instructions for running this program that is there stored in the main memory, and then the CPU will execute those instructions, and after the processing is done, this function returns 12, and then since we are using print statement here, this actually prints the output of 12 on our screen. We can actually look at running this program here in VS Code. We just write Python and then the program file name, and when we click it, we see the output of 12. So what actually happened was this function ran locally on my system. It would have occupied some memory when it was running, and CPU would have executed the instructions that were there, and finally we got the output 12 after the processing was done. This is an example of running a local function call. Similarly, you can write the same function in different programming languages like Java, C++, or any other programming language. Now let's discuss a different scenario. In this case, we have a server, let's call it S, it is running somewhere, and then this server provides a service of adding two numbers. And then there are clients which will basically call this service, which will first connect with this service and call this function as add, and they will pass the parameters. So similar to what we were doing in the local function call, the similar functionality we want to implement, but with a server. We do not want to run this function on the same machine that we were doing before. In this case, let's look at what are the challenges here of doing this. First one is that since we are connecting to the server, the client has to connect to the server. There can be network issues. So network issues can be that request can fail, like whatever the client is requesting, it can fail, or either the response can also fail. The server replies with a response that can also fail. The request timeouts can also happen, like whenever client is requesting something, there can be timeouts. The other challenge here is that we need to encode and decode the parameters and return values. In the previous case of local functions, everything, like every of the parameters and return values, all were stored in the memory itself, in the local memory. So we can easily access those through pointers. But that's not the case when your service is running on a different machine. We will first need to, like whenever we are sending a request and we are sending the number 2 and 3 and also the function add, first we need to encode this into bytes, because over the network everything is in the form of bytes. So first we need to convert this add to 2, 3 into bytes and send it to the server, and server then needs to decode this from the bytes. It needs to decode this into, like, this is the addition of, then it needs to decode the two numbers. So this is another challenge here, and it is very easy when the parameters, return values are of data type numbers and strings, but it becomes very complex when you are working with larger and larger objects. And another thing to keep in mind is that what if clients are written in different languages, like this client for example is in Python, and there is another client that wants to use the same functionality of adding two numbers, but this is written in C++, and then you can have another one in Java, let's say. So in this case, of course, this addition is, let's say, integers, like you have 5 and 7 integers. So this addition function supports two integers, addition of two integers, and it also returns an integer as an output. Then you need to make sure that all these clients also have similar data type, or if they do not have, you need to convert them, for example. So that is another thing to keep in mind. Now we will look at what are the different protocols that client and server can use when they are talking with each other. These are also called as APIs. API stands for Application Programming Interface, and API is a way for two or more systems, or here example client and server, to talk to each other. It's the process, like a set of rules and protocols that can help in doing this communication, that are called as API. And there are different styles of API, and we will talk about some of the popular ones here. First one is using TCP UDP protocol, or let's say TCP UDP API, for example. And this is a very common thing. Like if you have done networking in your university, you would have done socket programming, where you would have opened a server socket first, and then you would have connected with this server socket using a client, and then you have then like exchange some messages over the network. We can look at the example here. So let's go to socket, and you can see example of a simple Python server, and this is just a TCP server. So here you can see, for example, this is the main code of starting server. So you first create a socket, and then you select like whether you want to do it on TCP or UDP. You mention it here. Then you define what is the host and port on which this server or this service is going to be hosted, and then you bind this server to those port and IP address, and then you start listening. After you have bind it, you start listening on that port, and then you, like in a while loop, you keep waiting for the client to connect to this server. So that's what you can see on line number 23. That's what is happening. There is a while loop, and then this is waiting for a connection from a client. And once the client has connected, we receive the data from the client, and we store this in the data, and then basically we decode this data because we have received some bytes from the client. We need to decode this. So we decode this into num1 and num2, and then we add these numbers using, like we have a function here, add numbers. Like if you see at the top, there is function add numbers. We just returns the addition of these two numbers, and then we return like using the send function call, we return the result of this. And of course we encode it first. If you see here, first we encode it into bytes and then return this. That's why I told you, right, whenever we are talking over the network, we need to worry about like how do we encode the like whatever data we are sending. And similarly, when we receive a data, we need to decode that, like from bytes to, like for example, we did it from bytes to string, and then we actually like extracted the numbers from that. And then you can also have a look at the client code. In the client code, if you see, it just calls add numbers 5 and 7, and this is the main client implementation. Like here, first we have to connect to the server. So the server was running on this 1, 2, 3, 4, 5 port and localhost, and then we have to select like which, like TCP or UDP, like which type of protocol we want to use for this client socket, and then we basically then connect to the server. And once we have connected to the server, then we send a message to the server that like this is the message, like we have a message like just A and B, a string A and A comma B, basically the numbers A and B. And we, of course, first we need to encode it, because I mean in Python we have the string, but over the network we need to send the bytes. So we encode it and then send it to the server. And then when the server receives it, then we start waiting for the answer from the server. And that's why if you see, right, we are waiting for like receive. This is a blocked system call. So we are waiting for the server's answer. And when we receive a result from the server, we then close the connection, client connection with the server, and we just like return the result from like whatever result we got from the server. So this is a like example of one very basic protocol in which client and server can talk to each other. And here we see like how client is able to like use a service. That the service here is like service provided by the server is the addition of two numbers, and how client is able to use it. We can also run the program. So we can first start the server using Python, and then we start with socket and socket server.py. So first we start the server. So if you see, server has started listening on the port, like localhost is running locally on my system on port number 1, 2, 3, 4, 5. And now we run the client, Python socket, then we have Python client. So if you see, like in the client side, if you see the request sent was 5 plus 7, and it prints the result 12. And if you see on server side, it only outputs that like the client connected from port number 49965. So it received a request from localhost, and basically the client socket started on this port number 49965, and then connected with server. It sent the request of like adding 25 plus 7, and if you see it printed, it got the reply 12 and it printed it. So this is one example of communication like TCP UDP protocol example. Now let's look at what are the advantages and disadvantages of using this type of protocol. Like you have a TCP server and you are communicating directly to it. I mean, its advantage is the clients are very simple to implement here. Like every programming language has support for sockets. So you can easily create sockets in any other programming language, C++ or Java or Rust or Go, any programming. You can create the client like using the socket programming, and you can connect to the server. It's very easy. And also if the objects are very small, for example here the object was string, like that's what we were sending, like we were sending a string over the network. It was quite small, so it's very fast for those types of data structure. Disadvantages are like how do you handle complex objects. Like of course for string we can easily use the encode and decode function in Python, but what if you have advanced like objects like map, or you have a, let's say, structure for example, which contains a lot of like the struct itself contains integer, maps, list, all of this. So in that case it becomes a bit complex in this scenario. Another challenge here is its concurrency. Like in this example, we were just running a single threaded server. But if you want to like have a multi-threaded server, in that you have to write some custom code then to like maybe using some libraries in Python, you have to implement parallelism. Next is the failure handling. Like what happens if there are failures? Like the failure can, as I mentioned, right, they are communicating over the network. So failures can happen, like the timeouts can happen, request, response, all can fail. So how does the client and server handles it? So you need to implement those. So Redis client server is a popular example which uses this protocol, TCP UDP protocol. The Redis server runs on a TCP port, and the Redis client then connects to this port, and then they communicate with each other, similar to what example I showed. Of course, Redis communication is very complex from the example I have written. Now let's look at a different type of communication protocol, that is HTTP protocol, and this is a very popular protocol which is used by like clients to communicate with the web services. And this HTTP protocol of course uses TCP protocol underneath it for connection handling, like making the TCP connection and also handling those connection, handling the congestion and everything. TCP is used in this case. HTTP 3 does not use TCP. It uses a different protocol, but HTTP 1 and HTTP 2 TCP protocol is used for all this connection handling. And then in HTTP protocol, like what happens is you have client, and then again this is again a client and server model. So you have client, then you have server. And typically in HTTP protocol or web services, the clients either will be the web browser, or either they will be the applications like you have an Android application. There are also the clients which like connect with the server and they request something for you. And one of the popular style of communication over the web is using the REST API style. So this REST API uses a lot of features that are provided by HTTP protocol for communication between client and server. And in this style, the client sends a request, and in the request it has to mention like different parameters. Like one is like what is the type of request, whether it is GET request or a POST request. Then what is the path it wants to, like on the server there can be multiple resources. So in like REST API we typically discuss in terms of resources. For example, addition is one resource, then you can have a subtraction, you can have multiplication. Like all these functionalities are provided by the server. So first the client wants to say like, okay, this is the path, this is a resource, for example. Typically that will be the server name, and then you will have what is the like functionality, add, subtract, or whatever after that. And then client also mentions like in what data format it accepts the answer. Like for example, it can mention either as a text format, it accepts the answer from the server. It can also mention that in a JSON format, and then server also replies. Like you also want to understand, right? This client want to understand whether if there was some issue on the server or whether the response was as expected. So for that the server can use response code. 200 means like everything was okay, like 500 means like there was some issue on the server side while processing the request. So this way, I mean, client can understand if there are some issues on the server side. I'm not going to go into details of HTTP protocol. I have another video where I have already mentioned about that. So I will link that video in the details if you want to go in details of the HTTP protocol. Let's look at example of using a HTTP protocol or REST API over HTTP. So here we have a server. This is written in Flask, and you can see, for example, the resource is mentioned here, that addition of two numbers, and the method it supports is get, and then you define the function add numbers, and of course, if you see it, it gets the two numbers from the client. It parses those both the numbers from the request, num1 and num2, and then it does the addition of two numbers, and this returns the result. And if you see the format of returning, it returns it as a JSON. Similarly, in the request also, the numbers we accept, num1 and num2, they are in the form of a JSON. Now we can go into the client code, and we can see here we are adding two numbers, and this function implements that. Now first we define the URL. First you have to define the resource itself, the URL. Here we are running on localhost, so it's localhost and the port name. Typically when you are using public APIs, it will be the website name, and then you will have at the end like the resource itself, add or whatever resource on the website you are calling. And then you provide, for example, here I am again, if you see, we are using a JSON input that client will send. Here we have num1 and num2 as parameters here. And then you see here we are using the request library that is provided by Python to make a call to the server. And we, after this, like the request is completed, we receive the response, and we like pass the response to JSON, and we print the result. Let's look at RPC protocol. The reason that I was talking about like local function calls, then we discussed about a very simple like TCP server, TCP client, and then we discussed about like HTTP protocol, and like REST API being one of the popular styles that uses HTTP protocol for communication. The reason for discussing about all of those was that you understand like what are the different styles of communication. Like one is of course local communication, then you start communicating over the network, and over the network itself, like there are different protocols, there are different styles through which you can talk. And then now let's start looking at RPC protocol, and you will see that like how RPC protocol is different from other types of communication that we have seen till now. Of course, RPC again is a client server protocol. It's similar to what we have seen. There is a client, there is a server, and they both communicate with each other, and there is a protocol that they both have to follow when they are communicating. There is a set of rules. That's why this is called protocol. In RPC, the client makes a remote function call on a server. This remote function is also called as method or procedure. And this is also again a client server protocol or a request response protocol. That's what we have seen in other cases also, like all our client server protocols, because we are talking over the network. And it's also a form of inter-process communication, like two processes which are running on different systems. Like even in like HTTP protocol, the same thing was true. Like there were two processes that were running on different servers, and they were communicating with each other. But in the local function example, we just had one process, so that was not a process of inter-process communication. In all of these other examples of networking protocols, we have like one client process, one server process, both are talking to each other, and both are there on different machines. Now let's look at like if client and server wants to use RPC for communication, how that can be done. So first we need to define the service and specify the methods that can be called remotely with parameters and return types. So we need to define all the methods that this service will support, and we also need to mention that in a file. And this is done using interface definition language, or in short form this is called as IDL. Like frameworks, popular RPC frameworks like gRPC and Thrift, they use this language, interface definition language, to define the interface itself. Like this interface contains all the functions, the return types, and also the parameters to this function. You will see this is an example, then it will become more clear to you. And then we need a tool to compile this ideal file to generate code for both client and server stubs. Now, if you are hearing this word stubs for the first time, don't be confused. This is just a piece of code which is used for the remote communication in RPC. So these are some additional like code that is generated, like when you compile the ideal, these are extra files or extra code that is generated, and which actually helps in like as I mentioned, right, when you are talking over network, you need to think about how do you like encode the message that you are sending, how does the server decode the message, right? And there are other things like exceptional handling and other things that we need to take care of. And this extra code, right, that is generated, client calls this client stub and server calls this server stub, like whatever extra code that client is using, right? Because client will also need to, like whenever it receives a message, it will need to decode the message, and similarly when it sends a message, it will need to encode that message. So it will use those like client stubs that are generated to do this. And similarly, server will also use this server stubs to do the similar thing. And then you will have the server which actually implements the function that is defined in the ideal file. All these functions will be then implemented by the server, and then server will start on running on some port, and then it will start handling the client calls. And what the client will do, like since client also, like client can also use the client stubs that's generated when you actually compile the ideal file. They can use those stubs to actually call the server. And if when you see the example, you will see that it will become more clear to you. This is example of an ideal file where we are defining a service calculator service, and let's take a simple example where it provides only one function, that is addition function. It takes a request and then it returns a response. So that's how you need to define the function, like basically what is the function name, what is the parameters of this function. So we have defined request, and we'll see what this request is and what is the return value of this function. In this case, it's a response. And if you go and then we can look at what exactly the request is. If you look at the request, it's a message, and it consists of two numbers, both are integers, num1 and num2. And then if you look at response, which is the return value of this function, it's again a message, and if you see the return type of this, it's a result, and the result return type is integer. And once you have this ideal file, you can use some tool, like depending on framework, they do provide the tool to compile this ideal file and generate stubs. And once you have the ideal file and the stubs generated, then you go and write the server code. So we basically, if you see here, we start a server, and you need to register like what service you are providing. Like this server is providing the service of calculator service. And of course, like if you see this class calculator service, we are importing this from the stubs that we have generated in the like when we are compiling the ideal file. And then we register this service with this server, and similar to what we have done in like TCP server and TCP client and HTTP protocol, we register this server on some port and some IP address, and then we start this server. And here if you see, we have implemented the addition function. That's what we have written in the ideal file, right? That the server is going to implement this add function. And if you see here, it takes a request here, right? That's what we have also written here, right? It receives a request and it returns a response. So you see this function, the function that is defined in the server, similarly it receives that request what we have defined in the ideal file, and then from the request it takes both the numbers num1 and num2. It does the addition of both the numbers, and if you see in the ideal, if you see, there is the return type is response. So similarly, the return type is response, and we pass the result here, because the response, if you see what we have to pass in this, we have to pass the result. I mean, the result is the kind of part of response, so we have to pass the result in this response. Now let's look at the client call. Like if the client wants to use like the service that is provided by the server, like the addition of two numbers, how it can use it. So it can also create a like request, and in the request it can pass both the numbers, like request.num1 equal to 10 and request.num2 equal to 20, let's say. And then it can basically, I have hidden a lot of code here, but typically it has to connect to the server, and once it connects to the server, then it can ask the server to add these two numbers. And if you see here, like it is trying to use the calculator service. This is a service that is provided by the server, and asking just for addition. Like of course, like calculator service can provide subtraction and multiplication and other types of operation, but here we are just interested in add, and we are sending the request in that, and then we get the response from the server and we print that result. The example that I am showing you here is of gRPC framework. There are other popular frameworks also that uses RPC, but gRPC lately has become like the most popular one right now. So if you see the syntax of like how do you write all of this like ideal file, and how do you write the client and server using gRPC. So gRPC uses protobuf for communication over the network. Like if you need to encode the message, you need to decode the message, all of this is done by the protobuf. And here you can see, right, we are defining a service, calculator service, similar to what I have shown till now. You can see it provides this addition function which receives a request and it returns a response. And the request is of this form, like the request is the form num1 and num2. You can provide two integers, num1 and num2. And the response, the format is basically there is a result variable in this, and it is of type integer. And once you have the ideal file, you can use a tool provided by gRPC. So it should be mentioned in readme file. So you can see like here, like this protoc is the tool that is provided by gRPC to generate the, like, compile this ideal file and generate the stubs. So you can see like I won't go over the full syntax here, what I am passing here. Maybe in another video I can discuss in more details about gRPC, like how do you write code for it, what protocol, like protobuf, how protobuf is used in that, how do you create proto files, and how do you compile it. I can maybe talk in a different video. I am just going to give overview of gRPC here. So once you run this command, and then what happens is you get all the stubs generated, and here I am generating this in, like, here in this file, gen and then py, and you can see the stubs are generated here. Like you can go in this file, for example, calculator pv2 grpc, and like you can see there will be client stub and also server stub. For example, if you see, it mentions, right, client and server classes corresponding to protobuf defined services. Like whatever we have defined in ideal, it contains the client and server classes for them. So if you look at the first one, it is calculator service stub. So this is basically the stub that is provided for the client. So if client wants to talk to the server, the clients have to, of course this is for Python, so the Python client has to use this class calculator service stub to talk to the server. Similarly for server, like if server wants to implement the functionalities, like in the ideal file we have mentioned, right, the server needs to implement add function. So it will basically use this calculator service servicer. You have the addition function in this class, but it's not implemented, right? You see it's raise not implemented errors. So the server has to make sure that it implements this addition function. Then there is another function here, define calculator service servicer to server. So this is used to register that, okay, this, like this service exists, so you need to register this service, the calculator service, with the server, and in that this is very useful. Now we can see, like when we actually look at server and client, you will see like how they are used. Now let's have a look at the server code. On the left hand side I have the server code, on the right hand side I have the stub that was generated when I ran the command. Now if you see here, we define a new class calculator servicer, and this, if you see, inherits from a class that is defined in calculator pv2 grpc. Like this is auto generated file that's on the right hand side, and it inherits from the function calculator service, and of course this is the function here where the addition function is defined. And then what we do is we again like override this function addition here, we override it, and of course we provide implementation here of that function. With the implementation, that result is the, like, addition of both numbers, and of course we then return the response back to the like whoever is calling this with the result. And then like if you go down, you can see like in the main function, like serve, that is the first thing that will be called from main. If you see, like we are calling the serve function first, so this first creates the gRPC server with like how many like workers we want for the server. Here we have initialized it to 10, and then like we like create an object out of this class that we have here, calculator servicer. And the next thing that we need to do is very important. We need to register this, like whatever functionality we are providing, we need to register this with this, like with this server. Like this server needs to know that like this is the functionality that's being provided. So that's why we use another function, add calculator servicer service servicer to server. And you can see this was the function that we have already defined. Like this has been defined by the gRPC already. Like when you compile the ideal file, you can see this function is already done. Like this is being handled by the gRPC. Like we do not need to do all of this, right? Like all this complex stuff of like registering this function with the server, and also like encoding, decoding of messages. Like for example, here the request and response are the messages, right? All the encoding, decoding, all of this are taken care by the gRPC itself. We do not need to like write code for that. We just need to use that. Like, and here if you see, we are trying to like register this service with the server, and then we start the server on some port and IP address, and then we start the server using server start. And of course now when you start it, it's actually waiting for some request from the client, so it is running on some port. And then let's look at the client code also. Now if you look at the client code, that is on the left hand side, and similarly the stub code is on the right hand side. So if you see again, the main function calls run, and if you go to run, we see that we are first creating a channel. So in gRPC has the concept of channel. So through this channel, basically this client can connect with the server. So here we mention what is the IP address of the server and what is the port number of the server, and this will help in connecting to the server. And then we need to define basically the stub itself in the client. So we need to define, so if you see in this auto-generated file, we have this calculator service stub. And if you want to use any of the services provided by the service, like addition, subtraction, whatever, we need to use this stub to call the like function on the server side. So that's why we first like store this in a variable, and of course we need to also pass the channel itself because we are going to use this channel for communication. That's why we need to pass this channel to the stub. And we have the stub, we can use this stub for communicating with the server. So for example, here if you see line number 17, you can just call stub.add. So add is the functionality that's provided by the server. You can directly call it with the help of stub. Similarly, if there was maybe multiplication, you can just call stub.multiplication. And of course we want to send like we need to send some message to the server. So you need to send like two numbers that you want to add. So you need to create a request. So that's what we are doing on line 15. We are creating a request using the like request that we have defined in the ideal file. And if you again say we are using something from the auto-generated file, calculator pv2, where this is a request is a class, and you just pass the values 20 and 10 to this num1 and num2, and then you pass this to the you pass this request object to the addition, and then you wait for the result. And once you have the result, you just print the response or result. And in some cases, like if there are some exceptions, for example, like if there is timeout or if there are some errors, for example, in that case you can just to try and accept and catch those exceptions as well in gRPC. So let's try to run both of this code. So let me first start the server with rpc server.py. So the server is started, it's listening on port number 50051. And let me also start the client. So if you see, the client has sent the request. Like we are not printing anything on server side, but if you see on the client side, client is like requesting this, like addition of 20 plus 10, and then it receives the answer from the server, that is 30, and it prints it has 30 here. Now let's look at some of the popular RPC frameworks. gRPC, or Google Remote Procedure Call, which was developed at Google, is one of the popular one. And the example we saw right for the RPC, we were using gRPC. All the code examples that I have shown for RPC, that was using gRPC there. And there are other companies also which are using gRPC. Examples are Netflix, Reddit, LinkedIn also like migrated from RESTly. Reddit initially was using Thrift, but now they have migrated to gRPC. And there are other companies also, like you can open these links and read about them, like how they are implementing gRPC for communication. Then the other important and very popular RPC framework is Apache Thrift, which is used at companies like Meta, Twitter, Uber. Uber also uses gRPC and they also use Thrift. And there are other customers also which use Thrift. So these are like gRPC and Thrift are two popular ones. And lately, like gRPC is like being adopted by a lot of companies. Now let's try to look at differences and common things between RPC and REST. Like RPC and REST are like very popular styles in API design. And what are APIs? APIs are mechanisms that enable two software components. This is important, two software components, then to communicate with each other using a set of definitions and protocol. Like two things are important here. First is that there are two software components. So you have like in whatever examples we have seen, there are client and there are server. These are two software components. Like server is running one process and client is running one process, and they want to communicate with each other. And then you have to follow some definitions and protocols. And in case of REST and RPC, these are different. For example, in REST, the definitions that we saw, typically these are methods and resources, right? Typically use get method, and then you define also the resources. For example, we have done, right, something like HTTP, localhost, then the port number, like let's say anything 123, and then after that you define like what is the resource. Like for example, addition is the resource, then you define it similar something like this in REST. And the data format, like one of the popular data format is REST in JSON, like whatever request, like whatever data you want to pass in request and whatever data you want to receive basically from the response, those are typically in the JSON format. It's one of the popular data format. And this is for REST, as I mentioned, right, you need to define and protocols. And then in RPC, it's a bit different. The definition that we saw in RPC was very different from REST. In RPC, we have like ideal file in which we define the functions. And when the client has to make a request, they just define the stub and they call directly the function add, for example, which is very similar to how you do in like in local functions, right? You just call it using the function call. and it's very similar to that in RPC. Both have support in multiple programming languages. Like this is common thing. Like REST is very popular, and you can like have any client, right? You can write a client in Python. You can write one in Java, right, to call this function like HTTP function that's there. But as we have seen that RPC clients are more developer friendly. Like in RPC, when you define the client, right, you can just call stub.add, like which is very developer friendly, right? It's similar to how you are calling a local function. But in the case of REST, it depends depending on the programming language. For example, in Python, you can use the request library that's there, and then you can call the uh, service that's provided. And like if you're using Java, you have to use a different library for that. But in RPC, of course, for every client, the code will be different, but the concept will remain same. That stub will be generated, and from the stub, you just call that function like add, for example. Now let's look at the major differences between RPC and REST API style. And when you are trying to select between whether you should use RPC or you should use REST, you should consider these differences. RPC protocols with binary encoding format can achieve better performance than JSON over REST. So if you are using RPC protocol, and in the RPC protocol, you are using a binary encoding format. So like two of the popular binary encoding formats, one is of course protobuf that is used in gRPC. Then you also have the thrift format that is using Apache Thrift. Like both of these are binary encoding formats, and if you are using those format with RPC, then it can achieve better performance if you are using REST over JSON. The reason for this is that smaller size of data using efficient encoding process. So the encoding process in RPC is more efficient than that of REST over JSON. And when like if you have, let's say, a message M, and you want to encode using, let's say, some binary format in RPC, and let's say if you want to encode same thing in JSON, then this RPC one will produce the final output which is of a smaller size than that of JSON. And also the encoding process itself is very fast in RPC than JSON. So this has two advantages that we will see. So LinkedIn saw 16% reduction in latency and 8% improvement in resource utilization after they moved to gRPC. Like gRPC is one popular RPC protocols. Now the reason why LinkedIn saw two benefits, like one is of course you see reduction in latency. The reason is that the encoding and decoding process in RPC protocols is more efficient. They are more fast. So that's why they help in reducing the latency. In the JSON case, it takes more time for doing the same encoding and decoding of the message. And also, since the size of like the final output that is produced after encoding is smaller in the case of RPC, so that also helps in saving a lot of bandwidth, because you have to transfer this final output over the network. And if the size is smaller, let's say in RPC, it will be more efficient. Like it will make more efficient use of the network bandwidth that we have. The other differences in REST, client and server are not dependent on each other, but it's not true for RPC. So in like, let's say in the case of REST, if you want to implement a new function, let's say if you just want to implement another function called, let's say, subtract, then what you can do is you can just add a new route. So you can just maybe add subtract here, and then implement the subtraction of both numbers, and then you can return that result, right? And from the client itself, for client itself, it's very easy. It can use the same request library, and it can use the get request, and of course you just need to change the URL. So when when the client wants to do subtraction, instead of add, it can replace this add with subtract, and then it can call the function with the same request, and it will get the answer. It's very easy, right? Both are not dependent on each other here. Like both can make independent changes. But it's not true for RPC. Let's look at the example of RPC. Like if you want to do the same thing in RPC, what will happen? So in RPC, if you want to do the same thing, what you will do, first you need to define a new function. So you will define a new function here. So you will maybe define it as subtract, let's call it subtract. And then you will keep the request and response same, like request is two numbers, number and num2, and response is the result, that is the integer. And then what you need to do is, now you need to regenerate the stubs here, like because the clients needs to know about the new function that's there. So you need to use this command, like this command for compiling the ideal file again, because you are adding a new function, and it will generate some stubs. And of course I'm not going to do that here. And then there will be some changes that will happen in this files, right? In this file, of course, if you see here, only one add function was there, but then here a new function will be added. It will be, let's say, subtract, define subtract, and the same thing will be there. And similarly, when you compile the ideal file, you will also get an entry for subtract here, because client will also need to know about that function. And only when that, like this ideal file is compiled and these are generated, then only you can go and like do the implementation on server and client side. So like both are dependent on this ideal file here, like both are coupled with each other, and the coupling is because of this ideal file. If you want to use RPC over web, so right now like REST is the most popular API style over web. So for the REST API, we do have JavaScript support in the web browsers. So they can easily use this JavaScript to make calls to the APIs, the web services API, and they can get the answer back in JSON. And JavaScript has good support for JSON, so it can easily encode and decode that JSON. But that's not true for RPC. For RPC, if you want to use it over web, you will need to support the clients also, right? The clients need to be there in the web browser. There is gRPC web client, which you can basically include in the JavaScript, but the overall steps here are very complex. Like it's not very easy as for the what we do for the REST APIs. And REST is very good for experimentation and debugging. So if there is a REST API and if you want to test that REST API, it's very easy. You can simply use the curl command from your terminal and send a request to this REST API and get the response back. Now let's look at the use cases, like how companies or like people are using this REST and RPC. Like both are very popular, both are being used. So REST is like predominantly used for public APIs. So if you have web services and these web services have like let's say they are providing some functionalities, in this that case REST is the most popular style. The reason being REST is very simple. It has very good support in web browsers through JavaScript and JSON. So it's very simple in that sense. And there is also no coupling between client and server. RPC is now the dominant one in communication between microservices, like within the same organization. So this is so basically in the REST we talked about whenever there are public APIs. So the APIs which are hosted publicly, in that REST the most popular one. But for the APIs which are very internal to the organization, for example, like Google has a lot of internal services like microservices which are talking to each other. In that case, like RPC is becoming more and more popular. As I have shown you, right, a lot of companies are using RPC like gRPC and Apache Thrift. Companies like Google, Meta, Netflix, Twitter, all of those are using RPC for communicating between the microservices. And we have also seen like in case of LinkedIn, gRPC is replacing JSON with REST style. Like LinkedIn previously was using JSON with REST for communication between microservices. Now it is has moved to gRPC for that. But within the organization itself, uh, gRPC and Apache Thrift will be like more popular, because we saw in the case of RPC, right, the encoding process is more efficient and even the final output is smaller compared to REST. So that saves a lot of like resources for the company, and also it improves the latency of microservices. And feel free to share your viewpoints on RPC versus REST. And if you do disagree with my viewpoint, feel free to share it, because this will also help me learning about both of this. And at last, it also contains the references from where I have read about gRPC, Thrift, REST, difference between them, all of this. Like data, like one of the popular books is Designing Data Intensive Applications. It's a very good book for system design that helped me in learning about this like protocols like Protobuf, Apache Thrift, and difference between REST versus RPC. That's all for this video. And if you do have any feedback, if you have your own viewpoints or any thoughts, right, do feel free to share it in the comments. And the code that I have shared here, I have uploaded it to GitHub. So I will share that link in the description. So you can also go and try out those code on your own system also.